Hello. So this is the unit circle. We're going to talk about implicit differentiation. This is just a quick idea of what implicit differentiation can do. All those extra points on the circle right now are ways that I was trying to draw a better circle, so they're not very important right now. We know that the equation of this circle is x squared plus y squared equals 1 because it is the unit circle. We know that this isn't a function, but we can still take the derivative of it. The idea is just like what we normally do. We can look at a point and go, hey, look at this point. The slope of the tangent line would be 0, so there would be a slope of 0 right there. Over here we look and we go, hey, that looks like a slope of -1. And -1 is going to be right about here because that's got a radius of 1. The slope here is negative and less than -1, so maybe it's like here-ish. And then as we get closer and closer to this point here, you can see that basically it's going to become infinitely steep at x equals 1. And so we kind of have this shape that goes like that. So we are getting steeper and steeper and steeper as we go towards, as we move towards that point. And we can do the same thing going in this direction. So if we continue to rotate around the circle, here we can see clearly we have a slope of +1. And then it gets steeper and steeper and steeper until we are going to hit a vertical asymptote there. And that's not the best drawing of it. Yeah, actually it's not too bad. It looks like that. So it kind of looks, I don't know, kind of like this. That's kind of ugly, but I think we get the idea. So what I just did was sketch a graph of the derivative of the top half of a circle. I can do that for the bottom half as well, and this is where it stops becoming a function. The red thing is a function. So now I'm going to start sketching the other one. So if I look at this this point, it's got a slope of 0. But over here, we've got a slope of +1, which is about there. And so we're going to get this thing that also has a vertical asymptote that's associated with that in that direction. And we can see that it would have a vertical asymptote that would go that way. So the slope of this equation is this bizarro shape here that's not a function. So what we need to be able to do is take the derivative of something that's not a function. And we are going to add one simple rule that we've been following, but you're just going to see it in a slightly different way. And the only reason why we ignored it was just to make things a little easier and a little smoother for you. So check that out in the next video.